Okay, I'm going to do a quick review of all of the basic derivative rules and give you a guideline for all the ones you need to know. I'm going to start with the basic derivative rules, and it's really one rule, but I divided it up into three pieces. And the derivative of a x to the n equals a n x to the n minus 1. Crazy words, but what does that mean? It just means if we're taking the derivative of 6x to the fifth, that's equal to 6 times 5x to the fourth, which equals 30x to the fourth. The a is just a constant out in front. The n is the exponent from the top, and then we subtract 1 from the top over there. If we're looking at it another way, if the derivative of a just to the x, then the derivative is just a. Meaning if we're taking the derivative of 5x, we end up with just 5. The x's disappear. And if we're taking the derivative of a, the derivative is 0. Meaning if we start with a derivative of the number 7, we know the derivative of a constant is just 0. Now we're going to look at our basic trig functions. Remember, these are not inverse trig functions. These are regular trig functions. The derivative of sine is cosine of x, and the derivative of cosine is negative sine of x. Just remember, whenever we see a co-function we got to think of Coco, and whenever Coco takes derivatives, Coco cries. So if we take the derivative of a co-function, we will always have a negative answer to work with. So now we're taking a look at the derivative of tangent, and the other thing to remember is that there will always be 1 tan and 2 secants in any derivative we take, and with the cofunctions as well. So it'll be 1 cotangent, 2 cosecants. Remember that when we go to take them. Derivative of tangent is secant squared x. Derivative of cotangent is negative cosecant squared x. Derivative of secant is secant x tangent x. The derivative of cosecant is cosecant x cotangent x. Oh, that's right, with a minus sign on there, because all cofunctions will have negative derivatives. So just like this, we'll have a negative derivative. That's a negative sign. It's with it right there. And remember that with relationships between a function and their cofunction, their derivatives will just be the flips of each other. So these are your trig function derivatives. Look at Coco crying over there. Oh, Coco. The next big functions to look at, there's really 3 of them. 1, 2, 3, but I add a specific example in for those. A very important one is the derivative of ln of x. When I see the word ln, I think of the word line. So when I see its derivative, it's equal to 1 over x. The derivative of ln of x is 1 over x. The ln disappears and turns into a line. I think you see it with a line right there. Carrie Ann's favorite, the derivative of e to the x is e to the x. It's the only derivative, it's the only function whose derivative is itself. That's what makes it special. The derivative of n to the x is n to the x times the ln of n, where ln of n is just a constant that's multiplied onto it. So as a specific example, y equals 3 to the x is, the derivative is 3 to the x ln of 3. Where ln of 3 is a constant, you may also see it written as ln of 3 times 3 to the x. All of those are correct. Next thing we're going to look at are some general rules. The first one is the chain rule. The chain rule is when there's one function stuck inside of another function. U is the inside function, f is the outside function. So if we're taking the derivative of the function y, which is fu, calm down, Quinn, I know it's like that, but it's not bad. The derivative of fu is f prime u times u prime, which is the derivative of the outside, times the derivative of the inside. Remember, when we take the derivative of the outside, we don't touch the inside function. So for example, the derivative of secant of 6x to the third is, let's see, the derivative of secant is secant tangent. So the derivative of secant 6x to the third is secant, parentheses, the argument, 6x to the third, times tangent 6x to the third. I've taken the derivative of the outside, and then I'm multiplying that times the derivative of the inside, which is 18x squared. That's the complete rule on the chain rule. The product rule, if you're given a function uv, the product rule is u prime v plus uv prime. And for the quotient, it's u prime v minus uv prime over v squared. Remember that when using the product rule, the order of this doesn't matter. I try to keep it this way because then it matches the quotient rule, which just has a minus sign in there. Don't try to simplify these. Keep them the way they are. They're not going to simplify down, for the most part. And the last collection of things to look at are the inverse trig functions. Remember, they're a little strange compared to the other functions. I have a great mnemonic to help remember these functions. And just remember with the inverse trig functions, if you get 6 ticks, ho-ho, then you're going to be dead. And also remember that if Coco's involved, here's Coco, that as soon as Coco takes derivatives of cofunctions, oh, he's going to cry, as usual. So if we look at our original 3, sine, tangent, and secant, which are the original functions, it's going to be the following derivatives, but here they are, s, I, x, 6, t. That looks better. T, I, x, 6 ticks, and then bleh, you're dead. Remember that the tangent is the only one that's positive in the middle, but we see the x's right next to each other there. And we just remember that the cofunctions are the same derivatives, just with a minus sign. So those derivatives look like that, and they match up. And just remember that whatever the argument is, x squared, that's what goes in these spots right here. Here's a specific example. And this one could be a project to do. That's why I put this one on here, because the argument is this long function right here. So we have the chain rule, and first thing we'll deal with is the outside function, which is the inverse secant. So the derivative is equal to 1 over the absolute value of the argument, which is x squared plus 5x plus 2, times the square root of x squared, but not x squared, it's of the argument squared. X squared plus 5x plus 2 squared minus 1 times the derivative of the inside function, which is going to be this piece, which is going to be 2x plus 5. This answer is totally acceptable. You don't have to simplify it. You just have to make sure you carry the arguments with you. Hope this video was helpful. These are the derivatives you need to know. Be ready for them when we test them on Friday.